Okay, we're going to talk about polar coordinates, which is lesson 6.4. What we have is, instead of having on the regular coordinate plane with an xy axis, we have an xy coordinate. So if you think about this in terms of on an axis, if I draw in the x and y axis, so this is the x and this is the y. We're calling this the polar axis, and the pole is basically the origin. If I drew in the regular coordinates, I would draw a right angle, and we would go x units to the right and y units up. What we're going to have instead, and this is r from our unit circle back in the day, we're going to instead go with this r, and this angle theta is going to replace the x to the right or left and the y to the up or down. So if you think about a right triangle with an angle and an x and a y on a coordinate plane, instead we're going to be using the r and the theta, and those are going to be polar coordinates. These are rectangular coordinates. Why are they rectangular? Because of the right angle. Plotting points on a rectangular grid. All you're going to do is, if this is point P, and I'm going to go with an r of 2 and a theta of pi over 3, oh, heavens to Betsy, we're going to need to do some conversion from degrees to radians and back again, so please remember that pi radians is 180 degrees. Got it? Good. That's from chapter 4, pre-calc. So I'm turning to 60. I'm turning to 60, and I have a radius of 2. You turn to 60 with a radius of 2, radius 1, radius 2. Boom, there's my point. That's point P. Big stuff. Next one. I have an r of negative 1, and this is going 3 pi over 4 must be, I think that's 135. 135. So I'm going to go turn to 135, which is going to be right about here. And if I'm going to be negative 1, here I turn to 135, but then I'm going negative 1, which actually takes me backwards 1 to there. And that's going to be point Q. So notice an R can be negative, but it just kicks you backwards the other direction. So for that matter, this one over here could have been the point if I did negative 2, and but then I would have had to spun around to, I would have had to spun all the way to 240. So what if you spun all the way to 240 and then did negative 2? Look at all the way to 240 and then backwards. So all of these are going to have, you're going to have multiple ways to get there. And now I can tell you're really intrigued with the next one where the radius is 3, but we're going negative 45. Well, which way is negative? That's going to go this way, negative 45, and I'm going to have a radius of 3. I'm out here. That's going to be that point R. But this 3 negative 45 could have been 3 and 315. You get you to the same spot, huh? Kind of a terminal side idea. And I also could have done negative 3 and positive 135. Okay. And what if I had done, wait for this one, negative 220, -3, -225. Look at how fun this one is. I go -225, and then I go negative, so we go the other way. So there's going to be like multiple spots for all of these points. So plotting a point is just going to be in the r theta. I don't think that plotting a point is going to be overly difficult. I do have some polar coordinate graph paper, but oftentimes just sketching in your notebook is fine. Oh, look at that. There's the right answers. I just covered this. It means that all of these points have multiple ways to get there. The coterminal idea, we could go around another 360 and another 360 and another 360. Also means you can go backwards. The negative r takes you backwards. So we just saw there's a bunch of different ways. If they ask you for name another coordinate that lands in the same spot, that's what we just took a look at. Okay, this is going to be the big one. Since we know that x squared plus y squared equals r squared, this is the equation of a circle. And that's why we do this lesson after the conic sections. This is my circle centered at 0, 0. X squared plus y squared equals r squared. And since we also know that we have to remember back to the idea that the x-coordinate was the cosine and the y-coordinate was the sine. That goes back to chapter 5 pre-calc. And when you break this all down for solving for x and y in terms of our going between r theta and xy, this is your conversion stuff, okay? These are the things you really need to know. And it's really these three are the main ones. And then you should remember this comes back from chapter 5. It's the tangent is equal to the sine over the cosine. I think we remember that. So this r cosine and r sine and back again, and x squared plus y squared equals r squared. Those are the three. And this is how we're going to be able to convert our equations from one thing to the other. So when we start with this, it's as simple as find the rectangular coordinate of the point in the polar coordinate. So there's multiple ways you can do these. So this is r and this is theta, and it can be as easy as I'm looking for x equals r cosine theta. X equals 2 cosine 7 pi over 6. I don't know what 7 pi over 6 is. Must be about 210. So you're really looking for x equals 2 cosine 210. Can I find 210? Do I know what the cosine of 210 is? Chilling in the STC. Oh, it's all coming back to me now. I get a 30. I have a 30-degree angle in quadrant 3. I know it has to be negative. So 30-degree angle in quadrant 3, 30, 60, 90 triangle. So we've been doing this for years, right? We got the 1, 2, and the square root of 3, and the cosine of 2. Cosine of the 30 will be square root 3 over 2. So I'm going to have x is equal to 2 times negative square root 3 over 2. So this comes back to chapter 4 and chapter 3, and then my answer is negative square root 3, because I've got that 2 times that negative square root 3 over 2. Y coordinate, same thing, y equals r sine 7 pi over 6. Well, again, I'm in quadrant 3, chilling in the STC. I know that my sine is going to be negative, and sine is 1/2, so I'm going to get y equals 2 times negative 1/2, which is -1. So my answer is negative square root 3 and -1. And that's just using this x equals r cosine and y equals r sine, and we can transform ourselves into one thing to the other. Again, we're looking for exact values. Can't just plug these suckers into your calculator. We got to use our right triangle trig. Hey, look at that. We got it right. Find two polar coordinates. So now they've given me this is x and y, and they've said find me, we want to go to r theta. Okay. So I think the best way to do this is probably to draw a picture of 1 to the right and 1 down, and there's my negative, and we know the Pythagorean theorem is x squared plus y squared equals r squared. Then you can plug in the x and the y, and I end up with 1 and 1. I got the square root 2. And now we should recognize our 1 square root 2. This is a 45, right? It's a 45. So if I want to know what is the r is square root 2. I got that straight out of here with the 1 in there and the negative 1 in there. And then I've got my theta. It could be negative 45 or 315. You know, there's multiple ways to get that. So I would say my polar coordinate is if we're just going to go standard square root 2 in 315, there's nothing wrong with square root 2 and negative 45. So basically, the going from the xy to the r theta, you're going to just draw a picture. If it's not a nice angle, like this was a 1 square root 2, if it's not a 30, 60, 90 or 45, 45, 90, you can use your calculator and use the inverse key. Here we did it. Find two polar coordinates pairs for the point with the rectangular coordinate -8, -12. I can't remember if this one's in your notes. If it's not, make sure you want to add this. There should be some room. Again, I'm gonna go 8 left and 12 down, and I know I'm in quadrant 3, and so I'm going to use the Pythagorean theorem and do 8 squared and 12 squared, and I get the square root of 208, whatever that is. So x squared plus y squared equals r squared. 208 is r squared. If you want it as an exact value, I think it's 16 times 13. Who knows that? Why? But you can always do just the square root, depending on how they want it. It might not have a perfect square, so you could leave it as a 208, or you can do, I suppose you could do 14.42, but that's not an exact value, so please make sure that you're paying attention to that. And then you need to do the, you got to find the reference angle. So I would do inverse tangent. I would do the tangent of theta equals 12 over 8. So I would do inverse tangent of 12 over 8, and I'd get 56.3. Theta is 56.3. But you got to remember, we're a 56.3 in quadrant 3, so I really need 180 plus that 56.3, 236.3. So this is going to be my r is 4 root 13, and my theta is 236.3 degrees. So this is my r, this is my theta. I think that, what was that, 14.42 if you were rounding. They did ask me for 2 of them, so I could do, I could have done -4 root 13 and my 56.3, because that would bring me up to the 56.3, and then we bounce, and we bounce down there, and we end up in the same spot where things are doing well. Okay, last things we need to do, we need to convert. I think this first one, we have 2r equals 2 secant theta, and we're going to put this into rectangular form. Whenever we're doing these ones, we want to use the fact that y is equal to r sine theta, x is equal to r cosine theta, and x squared plus y squared equals r squared. So these are the things that you need to get them to. In order to get into an x, you need an r sine or you need an r cosine. And I think some of us remember chapter 5 pre-calc, and some of us had a good time. Secant is 1 over the cosine, and now I multiply both sides by cosine, and you can see what's going to happen here. Times cosine times cosine. 2 equals r cosine theta. Well, what's r cosine? Oh my gosh, it's x equals 2. Okay, so that's a vertical line, x equals 2, and I'm going to show you in the near future how to do this on your calculator, or not how to convert them on your calculator, but how to graph them on your calculator. You can't just convert them on your calculator. So we'll take a look at that. So that one was pretty simple. This is more difficult because it's right now it's sitting as a so again, you got x equals r cosine, you got y equals r sine, and you got x squared plus y squared equals r squared. So the first thing I need to look at is I don't have any of those things. But what I can do is I can multiply by r and multiply by r, because now I get r squared equals 6r cosine theta. So you have to introduce your own r. Why did I do that? Well, because of this. Well, looky here. X squared plus y squared equals, and then r cosine. Well, r cosine is x, so I get 6x. And now I have everything in x and y's, and what's going to be the next step? Well, this is going to go back to the conic sections, where we're going to bring this 6x over, x squared minus 6x blank plus y squared equals 0. And we're going to complete the square. Plus 9 plus 9 plus y squared equals 9. Well, what do we have here? We have a circle with a center of 3, 0 and a radius of 3. Yay! And we did that by starting off and introducing a new r. Okay, so you need to recognize that I need to come up with r cosines, r sines, or r squareds. That's what's going to set you free on these guys. Okay, one more type of problem. In order to put this in polar form, we are going to have to square these out. And again, we're looking for all of our x squared plus y squareds will turn into r squareds, and all of my r cosines will turn into x's, and r sines will turn into y. So the first thing we're going to do is we're going to square this. X squared minus 4x plus 4. Plus, now I'm going to square the y. I'm going to get y squared minus 6y plus 9 equals 13. And now I will minus 4 minus 9 minus 9. And look at x squared plus y squared minus 4x minus 6y equals 0. All I did is expand it out. This becomes r squared. This becomes r cosine. And this becomes r sine equals 0. And then we factor an r out of everything. R minus 4 cosine theta minus 6 sine theta equals 0, and I get r equals 0, or r equals, slide those two over, 4 cosine theta plus 6 sine theta. So what is this? This has to do with, it's kind of an extraneous. It's for building our rectangular coordinate. This is my answer. So we throw that out as extraneous. This is the polar coordinates for a circle. Look back up here with a center of 2, 3 and a radius of square root 13. And I'll show you how to graph that the next time I see you on your calculator. So now you can work on your 6-4 homework. It's a good time. Enjoy. Hey, look at that. We got it.